Good morning. Today I will present the solution of a flat plate exercise. So first we have to calculate the Reynolds, which is the velocity times the length divided by the kinematic viscosity at 303 Kelvin. To know this temperature, we have to calculate an average temperature between the temperature of the plate and the temperature of the air. Now, calculating this, we have a result of 633, which is a laminar flow. Then to calculate the Schmidt number, we have to divide the kinematic viscosity divided by the diffusion coefficient at 303 Kelvin, which gives us a number of 1.505. Then to calculate the Sherwood numbers, we have to use this formula, which we already calculated the Reynolds and the Schmidt, and we have a number of 19.145. Then, what is the film mass transfer coefficient associated with this process? To calculate this, we use the concentration times the K sub C. To calculate K sub C, we use this formula, that is the Sherwood multiplied by the diffusion coefficient divided by length, which gives us 0.1 centimeters divided by seconds. And to calculate the concentration, we use the ideal gas law, which is the pressure divided by the universal gas constant times the temperature, which is 4.02 times 10 to the minus 5 power mole divided by cubic centimeters. Then these results we replace in this formula, which give us a result of 4.02 times 10 to the minus 6 power. Then, how long will it take for the solvent to completely evaporate from the coating? To calculate the time, we use the total mole divided by the total molar flow rate. To calculate the total molar flow rate, we have to calculate first the molar flux, which is the mass transfer coefficient times the difference between the molar fraction of the solvent at the surface and the molar fraction of the solvent in the air far from the surface. We assume that this is 0, and we calculate this with the vapor pressure and the total pressure. Now, we replace these numbers and the number that we already calculated in the formula, and we have a molar flux of 2.01 multiplied by 10 to the minus 7 power. Then we replace this number and we multiply by the area, which give us a result of 4.02 times 10 minus to the minus 5 power. Then to calculate the mole, we have to use this formula, which give us 2 times 10 to the minus 3 power. And we replace these results in the formula that we have here and give us a final result of 49.75 seconds. Thank you.